Today's topic is combined inequalities, and they come in two flavors or sorts. One would start out something like this. Negative 3 is less than or equal to x minus 2, which is less than 4. You can see that the middle of this is x minus 2, and the basic sentence means that negative 3 is less than or equal to x minus 2, and also x minus 2 is less than 4. So the first step in solving either type of inequalities is to separate into two different inequalities. And this is actually the only challenging part. Notice that that is one of them, and the other is here. You need to include this entire quantity in each of the inequalities. So you have to first separate and then solve and graph. So I'm going to add 2. So negative 1 is less than or equal to x, and x is less than 6. I think that you know that the word "and" in English is a conjunction, and these types of combined inequalities in which there are two things that are both have to be true, and is what this, so and goes with conjunctions. So we have to separate and then solve and graph. So now we take this information, and then I hope you remember on the very beginning I said when we have these where x is between two numbers, and that's true, if negative 1 is less than or equal to x and x is less than 6, then that means that that's in between. We like to write them in order from least to greatest. Then I just have to graph my critical numbers. That's a closed dot because it's less than or equal to. This is an open dot because it is less than, and it's the space in between. And all graphs of conjunctions look like this. It's the space in between numbers. The other type looking something like this. 2w minus 1 is less than 3. Or, now this one is or, not and, 3w is greater than or equal to w plus 10. Well, these are already separated for you, which makes them quite easy. We just are going to solve them then. 2w is, why did I add 2 to both sides? I was obviously not paying attention. So I have to add 1 to both sides. 2w is less than 4. Which makes w less than 2, or, got to get my variables on one side, 2w is greater than or equal to 10, so w is greater than or equal to 5. It's a simple thing to go straight to the graph. I graph my critical numbers, meaning these, and by the way, if they're fractions, you just put them on as fractions. So here's my 2. It's an open dot, because it's not greater than or equal to, that doesn't look very open. I want to fix that so that it's clear. So if I put 2 here, it's an open dot at 2 and a closed dot at 5. W is greater than or equal to 5, which means it could be 5 or any number that's greater than 5. W also is less than 2, not including 2, but less than 2. And you will see that this is true. The disjunctions, and that's what these are called when it's connected by or. It is called a disjunction. They always have these graphs that go outward from two different numbers. So these concepts are pretty simple. Once again, throughout this entire chapter, you really have to pay attention to negative numbers. So if I, for example, say negative 3 is less than or equal to the opposite of x, which is less than 4. Again, I have to separate these. I have to say negative 3 is less than or equal to negative x, and negative x is less than 4. And this means that 3x, just like I always multiply by a negative number, but if I am multiplying by a negative number, I always have to remember that the sign switches. And that means that x is greater than negative 4 because I'm basically multiplying by negative 1. Now, if I want to write these in the order in which they appear on the number line, I'm going to say negative 4 is less than x, which is less than or equal to 3. Get used to this. Notice my small side is pointing to the negative 4, so when I flip it, it still has to, the small part has to still point to the negative 4. X here, the point is pointing toward x, so it still has to point toward x here. The moral of this story is don't forget about your signs. There's an open dot at negative 4, a closed dot at 3, and this is all of the numbers in between. It is a conjunction. And I think that that's basically it. I want to do the one thing that people were having trouble with in class is when it started like this. Negative 2 is less than y minus 2, which is less than or equal to 1. Don't forget the ways to separate this. All of y minus 2 has to go in each of the inequalities. Okay, so don't forget about that. When you separate them, the rest is easy peasy.